Math Linear Systems Trigonometry Project by Toby Yang. Planning the trip. So, for my first destination, it was Washington, D.C., and the distance from Sac to Washington was 603 kilometers. Destination 2 was Detroit, and the distance from Washington to Detroit was 645 kilometers. And finally, destination 2 back to Sac was 350 kilometers, and all this was found using Google Maps. Car rental companies. So I asked ChatGPT to give me some car rental companies pricing for my trip. Since the trip is going to take 3 days, it gave me these numbers. So for company A, it charges a flat fee plus cost per kilometer. And I got y equals 0.25x plus 120. So the cost per kilometer is 25 cents, and the flat fee is $120. For company B, it charges a higher flat fee than company A, but a lower cost per kilometer. And I got y equals 0.15x plus 240. And finally, for company C, it charges only a flat fee, but it is higher than both company A and B. So I got $350 for the flat fee for the entire trip. Creating the graph. As you can see, this is the graph using Desmos. The red line is representing company A, the blue line is company B, and the green line is company C. Finding the intersections between company A and B. So I had to use elimination to find the intersections between A and B. First, I had to set up the two equations on top of each other. Then I rearranged the equation to make it easier to eliminate, as you can see here. Then I subtracted the two equations to eliminate a variable. In this case, it was y. Then I solved the equation for the variable, which was x. So as you can see here, I subtracted, which equal to minus 0.10x equals to negative 120. And then once you divided negative 120 by negative 0.10 x, or negative 0.10, equal to 1,200. And then finally, I put that value, which was 1,200, back into the original equation to find the value of y. So therefore, the intersection between company A and B is 1,200, 420. Finding the intersections between company B and C. So using substitution, I first wrote out the equations. Since y had a direct value, I just substituted it into the other equation to find x. So as you can see here, this is what I did, which eventually totaled up to 733.33 equals x. And rounding it, therefore, the intersection between company B and C is 733 and 350. Drawing the triangle. So here, H is Sac, A is Washington, D.C., and B is Detroit. The side lengths are labeled here, and yeah. Finding the angle A. To find angle A, I had to use cosine law. Using the formula, I rearranged the equation to equal to the angle A, and after plugging in the numbers, I found the angle A, which totaled to 32 degrees. So therefore, the angle that separates Sac and Detroit from the point of view at Washington, D.C. is 32 degrees. To find angle B, I used sine law. Because I was finding the angle, I put the side length on the bottom because you could not isolate a variable in the denominator spot. After moving B to the other side, I plugged in the numbers which allowed me to find angle B. and using the ants, which was the exact not rounded degree from angle A, I found that the angle B equal to 67 degrees. And therefore, the angle that separates Sac and Washington, D.C. from the POV at Detroit is 67 degrees. Finding the angle C. Angle C was found by using the angle sum theorem, which states that all interior angles of a triangle has to add up to 180 degrees. Using this, I just subtracted 180 by 32 and 67, which allowed me to find the angle of 81 degrees. And therefore, the angle that separates Detroit and Washington, D.C. from the point of view at Sac is 81 degrees. Analysis of the trip. What do the points of intersection represent in the context of this car rental scenario? So the points of intersection represent the distance at which two car rental companies cost the same. These points show where one company becomes cheaper than another depending on how far you travel. Which company offers the best deal for the total distance of your entire round trip? So Company C offers the best deal because for the total distance of 1,598 kilometers, its flat rate of $350 is less than Company A and Company B. The points of intersection on the graph show that beyond certain distances, Company C becomes the cheapest option, and 1,598 kilometers is well beyond those points. Using your preferred company from question 2, determine algebraically how much it would cost you to travel the total distance of your round trip. So using Company C's equation, the cost remains constant regardless of the distance because of its flat fee. Therefore, the total cost for the trip is $350. Consider the leg of your trip from home to destination 1. Which company would be cheapest for just this leg of the journey? Company A is the cheapest for the 603-kilometer trip because its total cost is lower than Company B and C. Although Company A has a higher cost per kilometer, the distance is not large enough for it to exceed the other companies. And in the graph, you can see that Company A, which is in red, is the lowest by around 603 kilometers. Using the angle you calculated at home and the destination 1 and the distance of the leg home to destination 2, verify the distance from destination 1 to destination 2 using the law of sines. So I verified the distance from Washington to Detroit by using sine law. Plugging in the number I already had, I moved angle H over isolating side length H. I solved the equation, which equaled to around 652 kilometers, which is accurate and really close to 645 kilometers. The numbers are a little bit different because of the rounding of those degrees. Thank you for listening.